Hello, I am going to go over 6.01 Formation of the Solar System lab with you so that you understand exactly what to do. This is an example of a lab where I recommend the 3-tab method, 1 tab for this video, 1 tab for the simulation in Buzz, and 1 tab for your actual lab report. I recommend that you watch a little bit. Actually, I recommend you watch the whole thing first and then go back and watch a little bit, pause it, do what I did, go back to the video, watch a little bit, pause it, and then repeat the steps to work through the lab. All right, let's get into it. You're going to find the Google Forced copy right here in Buzz. When you get there, you're going to click on the link. It's going to ask you to make a copy. Go ahead and make that copy. The very first thing I want you to do once you've made the copy is go up to that share button, click the share button, and add my name so that I'm able to grade your work. So just add Kristen Lohoff and done. And then once you you submit your work, you're not going to get a message back from me saying, hey, give me sharing privileges, please. All right, let's go ahead and open up the simulator in the lesson pages now. If you've gotten to this lab, that means that you have taken the time to read through all 6 pages in this lesson first. Don't shortchange yourself because, especially with this lesson, the lab really depends on you understanding the different ideas that are mentioned within the lesson. All right, so let's go to that last page. We are working with the law of gravitation. Let's get in here. Here we go. Welcome to the space headquarters of Intergalactic Terraforming, the first company dedicated to creating Earth-like planets. We're glad to have you as our new Terra engineer. Proceed to Space Command to begin your training. All right, this lab is going to force you to go through this 3 steps in order. You can't just jump around. So this is unfortunately the kind of lab that once you start it, you want to work all the way through it, or you're going to have to start at the beginning again the next time. Mission introduction. For a planet to support life, it must be within the habitable zone of its solar system. The habitable zone of a solar system is the region around a star where a planet can maintain an atmosphere and support liquid water on its surface. Water is essential for successful terraforming. As a Terra engineer, your goal, your objective, is to position planets in the solar system so that some will fall into the habitable zone. This is necessary for future terraforming. Head to Space Academy to learn how the mass of a star and the location of planets within the solar system affect planetary orbits. All right, so here we go to the Space Academy. Distance. This is a concept that was taught within the lesson pages. A star has its own gravitational force that pulls astronomical objects toward it. This gravitational attraction causes the planets around a star to move in an elliptical orbit. Terra engineers adjust the orbit of a planet by changing the mass of the central star. They can also adjust orbits by changing the distance of a planet and surrounding planets from its central star. If you are in WVS Plus and you attended classes or watched the video on this lesson, we talked about how gravity is impacted by the mass of the objects and the distance between them. That's exactly what they're talking about here. Select an arrow to adjust the planet's orbital position. Note how the speed of the planet changes when the planet's distance changes. After you explore all adjustments, you can select the next button to continue. All right, so we can see we are on this outermost ring. I'm going to move in and watch what happens to the speed of the planet as it gets closer to the star. Okay, let's move further away. Look at the speed of the planet. It's closer to the star. What did you notice about the speed in relation to distance from the star? Where is it faster? Where is it slower? The revolving speed of the planet is also dependent on the star's mass. Select the arrows to adjust the star's mass and the planet's distance. Note how the speed of the planet changes with each adjustment. All right, so I'm going to decrease the size of the sun. Watch the planet. I'll increase it. Watch the planet. Not a huge change, but there is a slight change. Now, if I move it closer and I make the sun smaller and then bigger, slight change in speed. Closer to the sun. Again, just look at the difference moving further from the sun, closer to the star, I'm sorry. And now if I make the star smaller, oops, wrong way. Okay, now we are in the closest orbital path. Let's make the sun or the star bigger. Well, that we can notice. That is very noticeable, the speed. So what's happening as the star mass increases? What happens to the speed? Here's the star mass smaller. So I'm going to make the mass of the star bigger. What happens to the speed? The force of gravity. Or if I move further away, we've learned about those two different concepts. Fill in the options faster or slower for each of the following sentences. Record the correct observation statements in your lab report before moving to the Space Explorer. Okay, this is the hypothesis. So let's take a look here at our lab report. Go ahead, put your name, my name, Kristen Lohoff, Mrs. Lohoff, the date and the name of the lab. It's called Formation of the Solar System. Objectives. What, in your own words, is the purpose of this lab? And then here is the hypothesis section, and it has the blanks here. It has blanks here. Oh, this is not, where do we put the, here we go. In the data table, this is the part we're doing right now. When the mass of the sun is larger, Earth moves around the sun at a faster or slower pace. I'm going to put slower for all four just so that it lets me get through this. You should not do that. You should read the sentence, pick the word. Oh, look, it even tells me if I'm right or wrong. So it's going to tell me the correct answers, then copy that information into your lab here in that beginning data section, and then we can move on. Here we go into the Space Explorer. There we go. Astronomical objects exert a noticeable gravitational pull on one another. The strength of the gravitational force between objects depends on the distance between them and their masses. The position of one planet in a solar system affects the orbits of the other astronomical bodies near it. A Terra engineer must carefully select the distance of each planet to get as many planets in the habitable zone as possible. In addition, all planets must orbit the star successfully, regardless of the sun's mass. This is Solar System X. Your goal, your objective, is to get as many planets into the habitable zone of the Solar System X as possible, while still keeping all planets in orbit around the sun. The location of the habitable zone within Solar System X depends on the star's mass. The larger the mass of the sun, the stronger its gravitational pull, and the farther out from the center the habitable zone will be. There are three possible masses for the sun: 1x, 2x, and 3x. There are 8 possible orbits for you to place each of the 4 planets. Orbit 1 is the smallest orbit closest to this star. Orbit 8 is the furthest one out. Hypothesis: predict which orbits you will place the 4 planets based on the sun's mass. Record your hypothesis in your lab report. This is important. Are you listening? Make sure that when you record and you select, you record it right away, because you're going to need to follow these directions later in the lab and you won't be able to come back to the screen to see it. So if the mass of the sun is 1x, you're going to have, I think, 2 trials for 1x, 2 trials for 2x, 2 trials for 3x. You need to pick 4 orbits that you want to put your planets at in order to have them orbit that sun successfully. So if it's 1x, I'm going to pick 1, 2, 3, and 4. Now I need to come into my document, and up here in the hypothesis, the mass of the sun is 1x. I need to put in my orbits that I've picked. 1, 2, 3, and 4. Then come back, and for this one, I'm going to pick 2, 3, 4, and 5. And then I'm going to record it here. If the sun mass is 2x, 2, 3, 4, and 5. And then for this one, I'm going to pick 7, 8, 1, and 3. I'm just randomly picking numbers. 7, 8, 1, and 3, right? Yep. Okay, so now I've copied that, so I have my directions here that I'm going to refer to when we get to the trials. Click Next. Here is trial 1 for sun mass 1. Drag and drop the planets into the selected orbits that I picked. All right, so I'm going to have to go back and look. I said 1, 2, 3, and 4. All right, so I'm going to put the planets. Doesn't matter which ones I put. They are all the same mass in this experiment. 2, 3, 4. And now I'm ready to begin to see if they stay. So I have placed 4 planets. I've placed a planet at 1, 2, 3, and 4. And they are all in the habitable zone right now. Let's see if they stay there. Count how many planets are in the habitable zone shown in the red rings and how many are orbiting successfully. Are the planets still there? That depends on the star's mass. If the planets were too close to each other in orbit, their gravitational attractions caused them to collide. If planets were too far from the star, they moved out of orbit. If planets were too close to the star, they could have swerved into the star. So let's see what happens. Oh, these guys didn't move. Oh, they collided. Some planets merge into each other and collide due to being too close. Record the orbits you placed each planet in and how many fell into the habitable zone and how many were there at the end. So we have 2 remaining. Here's what I need to do. This is the most confusing part. I had a planet orbiting at 1. I had a planet orbiting at 2, a planet at 3, and a planet at 4. I had all 4 in the habitable zone, but only 2 survived. Now I'm going to try again. So I'm going to try putting them different places. So let's say 2, 4, 5, and 7. I need to remember that 2, 4, 5, and 7. Same thing. 2, 4, 5, and 7. Oh, one floated away. Oh, 2, 4, 5, and 7. Some planets float out due to the orbit being too far from the star. 2, 4, 5, and 7. All right, so I had one at 2, 4, 5, and 7. All 4 were in the habitable zone, and 3 made it this time. So a little better than last time. All right, next trial. Now our sun is mass 2x. And to start, I need to follow what my prediction was. I said 2, 3, 4, and 5. So let's put one at 2, 3, 4, and 5. And begin. Same text. Oh, 2 of them aren't going to make it. 2, 3, 4, 5, right? 2, 3, yep, 2, 3, 4, 5. All right, we're going to record it in here. I had 2, 3, 4, 5. All 4 were in the habitable zone, but only 2 made it. And now I would do another trial. This time I can put them wherever I want based on what I learned. Just remember the numbers so that you can record them in the data table. I'm going to go ahead and do that, and I'll meet you back here in just a minute. All right, so I've completed all of the steps. I have not included the numbers in here for you. You will be entering numbers and completing the table. Once that is done, you need to make sure that you copy that data table into this box right here. So this box should match what you have on this screen. And then we move on to the next. Next, you're going to have some questions. And let me look. I don't think that was done already. Yeah, I don't think, no. But I want you to read them. You're forced to go through them. And one of them is going to help you because right here it's going to help you identify the independent and dependent variables. You've completed 3 terraforming trials and all tests. What was or were your test or independent variables? The independent variables are the things that change. What was different each time? The mass of the sun and the initial location of each planet, the planet's new position in the solar system after each adjustment, or the change in the planet's distance from the sun only. Well, we changed the size of the sun as well. Is that right? That is correct. That's your independent variable. Go ahead and copy it into your lab report in independent variable. Next, in all tests, what was or were your outcome or dependent variables? That's what you measured or recorded. What numbers did we put down? Did we put down the mass of each planet and its distance from the sun, the planet's final location in motion and the location of the habitable zone, or the change in the planet's distance from the sun only? Well, we recorded that final location. That is the dependent variable. Go ahead and put that in your lab report. Next, you've got some questions to answer, and it's only going to let you pick the correct answer. I'm going to work through those, and I'll meet you at the other end of this. All right, here at the conclusion of those questions, it thanks us for our work, and it reminds us to take that data table here. If you didn't already, you can still look at it before you leave to get that information and copy it into your lab report. Once you hit reset, it's gone. So now you should have everything done here except the conclusion questions. Just double checking. Yep. And there are 5 conclusion questions. Make sure that you answer them using complete sentences. Make sure you're doing your own writing and you use what you learned in the lab to answer the questions. Don't make it harder than it is. All right. First, you're going to summarize what you did and what you saw. Then you're going to answer the next questions. All right, if you need extra help, come into a connect time or a support session, set up an appointment with me, send me an email, voice message, and I am happy to help you out. I know this was long, but this one was a little kind of all over the place. So good luck. I look forward to seeing your work. Bye, guys.